Okay, so let's get right into it. This explainer, it's going to challenge something we all take for granted, something really, really basic about the world. I mean, you look around, right? You see separate, solid things. But what if that's just, well, an illusion? What if, when you get right down to it, everything is connected in one single, vast, unbroken flow? You know, we go through life seeing all these distinct objects and events. There's a chair, here's a thought, up there's a star. It's just how our brains are wired to make sense of it all. But what if that's only skin deep? What if the real nature of reality isn't a bunch of things, nouns, but is actually a single, continuous action, a verb?
All right, so to really dig into this, we've got to go way back. We're going to look at some ancient ideas that question this whole concept of solid things. And believe me, this is not a new question. People have been wrestling with this for ages.
So this really frames the central mystery for us, right? On one hand, you have the common view. The world is basically a giant box of Legos. It's built from all these tiny, separate, fundamental parts. But on the other hand, you have this ancient view that reality is more like a river. It's a single, undivided, constantly changing whole. And that's the big question we're asking. What's more real, the Lego bricks or the river's flow?
Philosophers have been whispering about this for centuries, that the universe is more of a process than a place. The Greek thinker Heraclitus said this great line: you can't step into the same river twice. Why? Because it's always flowing, always changing. And then you've got the Buddhist doctrine of momentariness, which is this idea that nothing really lasts. Existence is just this incredibly fast series of moments, flashing into and out of being.
Pop, pop, pop. Okay, so that's the philosophy, but where does science come in? Well, science eventually picked up this trail, and for a little while, it looked like physics was actually going to confirm that ancient idea, the idea of a smooth, flowing reality.
Yeah, for a while there, it really seemed like physics was on board with this fundamental continuum idea. I mean, think about Einstein's general relativity. It pictured the universe not as some empty box, but as this dynamic, flexible fabric, space-time. And this fabric could bend, it could stretch, it could even ripple. In that picture, there are no gaps, no pixels, no seams. It's just one smooth, unbroken whole.
But then, everything changed. Quantum mechanics crashed the party. And the quantum world, wow, it revealed a much, much stranger picture. It was grainy, it was jumpy, full of weird probabilities and what Einstein called spooky connections. It totally complicated the search for what reality is really made of. It made everyone ask, is that smooth fabric of space-time really the final answer? Or is there something else going on underneath?
And that question, well, it leads us straight to our prime suspect for what that deeper reality might actually be. It's a pretty radical idea, and it comes right from the heart of quantum mechanics itself.
Okay, so here it is, the universal wave function. Physicist Sean Carroll makes a really strong case that we should take this thing seriously, like as fundamental reality. So what is it? Try to picture it like a single continuous mathematical ocean, an ocean that holds the potential for every possible state of the entire universe. And the crazy part is, in this view, it doesn't randomly collapse or make choices. It just evolves, smoothly, predictably, branching out as it goes. Now, this is a huge, radical shift in how we think about everything. Because in this picture, space-time, the thing we think of as the container for the universe, isn't fundamental at all. It's what we call an emergent property. It's something that grows out of that deeper quantum reality, that wave function. So space-time isn't the box. It's a pattern inside the box. So, what does this actually mean for us? The crucial takeaway here is that our whole universe, everything you see, everything you know, might just be one branch of this ginormous flowing wave function. Every single time a quantum event could go one way or another, the wave function just branches, and each possible outcome plays out in its own world. So what's the glue holding our branch together, giving us the space-time we experience? It's quantum entanglement. Those deep, spooky connections are like the threads that weave the very fabric of our reality. Okay, so if this continuous wave function is the real foundation of everything, then what does that do to our story of the Big Bang? How does that change our whole understanding of where it all came from? I mean, does it even make sense to talk about a beginning anymore?
All right, so the classic Big Bang story, that's the one with an absolute beginning, from nothing, a hard edge where time itself just starts. But a lot of modern physics models are trying to get away from that weird singularity. For instance, you've got the Hartle-Hawking model, which kind of smooths out the beginning, so there's no sharp edge. Then there are cyclic models, like from Roger Penrose, that imagine our universe bouncing or resetting from a previous one. And in Sean Carroll's view, the wave function is just eternal. It was always there. Our Big Bang wasn't a creation. It was just the moment our particular branch of it popped into existence in a very special, orderly state. So you see the theme, right? Our beginning starts to look less like a true creation and more like a transition, a change of state within something much, much bigger and older.
And all of this brings us to a totally new way of seeing reality. It's not built from the bottom up, with little particles getting stuck together to make bigger things. Instead, it's like it crystallizes from the top down, out of one single unified whole. So let's give these things we experience a name. How about continuum packages? Think of them as just temporary, localized patterns that kind of crystallize out of that universal continuum. They aren't really separate. A particle, a star, even a thought. It's like a whirlpool in a river. You can see it, it has a distinct shape, but it's not separate from the river, right? It's just the river temporarily spinning in a certain way. And eventually, it just dissolves right back into the flow. So you can think of existence as this constant rhythm, a four-step dance of appearing and disappearing. First, you have the unbroken whole, the continuum. Then, step 2, some kind of pattern or fluctuation forms a temporary boundary. Step 3, we perceive that pattern as a package, a thing, a particle, or maybe a thought. But then, step 4, that boundary fades away and it all dissolves back into the unbroken whole. And this rhythm, this could be happening all the time, everywhere, from the tiniest quantum flicker all the way up to the thoughts popping into your head.
And that right there is the core takeaway. If this way of looking at things is right, then the universe isn't a collection of nouns. It's a verb. It's not a static collection of stuff. It's a dynamic process of becoming. The most fundamental thing about reality might not be the things in it, but the rhythmic process of existence itself.
And so that leaves us with one last really big thought to chew on. We've talked about particles, space-time, the whole universe, but what about our own minds? If a single thought is just one of these temporary packages, a momentary wave that appears and then disappears, a wave in a vast continuum of consciousness, then what exactly is the ocean that it's coming from? And that might just be the deepest mystery of them all.